We also asked you to calculate the total cost for rain gardens, and that's pretty straightforward because we've already had you calculate the overflow for the rain gardens in a previous video, and the one where I show you how to actually do the rain gardens. We go through this workflow where you have the rain garden polygons and you calculate their area, and then you join that to the zonal statistics that gives you the summation of the flow over those watersheds defined by each rain garden. When you join those two together, then you have a data layer, data set, where you have these rain gardens with the area of the rain gardens, and then you can calculate the volume that each rain garden holds and see how that compares to this zonal sum of generated rainfall. And you calculate either an overflow or a deficit that the rain garden can still hold, and we talked about carrying that down in the network of watersheds through your flow network. So you can do that manually, but when you have that, then volume, or really area for each of the rain gardens, you can add a field that is just a cost field, and the cost is calculated by basically that value of the area, right, shape area for each of the rain gardens times 90, the cost per square meter of building a rain garden. And so you get basically for each of the rain gardens this added column, and then you can sum that column and get the cost. So that's pretty straightforward. The last thing you have to do is to calculate some costs associated with converting pervious area from impervious area, and here's a workflow that does that. So I start up here with my base surface permeability. So that's just your original data. I copy the original surface permeability that we had, the pervious, impervious, and I calculate the geometry attributes for that. So again, I make sure that I have a current shape area for the areas of each of the polygons in square meters in my coordinate system. And then I get the summary statistics, and the summary statistics I summarize by a case variable, the max first type. Remember, that has the value of pervious or impervious for the two different types of surfaces we had for each of the features. So a feature was one or the other. And so I have this base surf perm layer, and I output a table called base surf perm statistics that has the value for each of those. There'll be 2 row entries, one for pervious, one for impervious. Then it'll have the area in another column for those. And so I'll alter the field. What I want to do is rename it, because I'm doing the same thing coming down here. I have the modified surface permeability. That's the base that I took and split out areas that I then gave the attribute of pervious to. And so these are 2 different layers, very similar. They have the same feature boundaries, but some of the features had been split with added boundaries and had been changed to pervious to represent my pervious layer. So I do the same thing, calculate the geometry for all of those, modify them, get the summary statistics, and then I'll alter the fields here also. And the reason I alter the fields is because the output from the summary statistics, since these have the same named input variables, are going to have the same named output variables, and so I have to rename the fields. And so what I will go do here is open this and show you this alter field command allows you to take the input table and the input field name, give it a new field name and a new field name alias. I'm giving them both the same, so it'll show. So this is the modified area that I'm taking my sum of the shape area, and for my modified data layer, I just changed the name to modified area. Same thing here for my base data layer, right? The sum shape area, what gets output from the summary statistics, but I'm going to change its name to original area, and the same thing for the alias, so it gets displayed as original area. And so now I have 2 data layers, I should say 2 data tables. Both have a pervious and impervious name in the row, and then they have the corresponding sum area. But the columns are now named, the modified and the base variables, and so I can join those two tables. And when I join those two tables, then by the modified or max first type, I get a table that comes out that is joined by this max first type and has the area originally and the area modified. And so I can then convert that table. I have to do this table to table after the join, because I want to convert that temporary join into an existing new permanent table. So I take that joined table and I output it to my permanent data, not my scratch, but my permanent data, this perv_conv table. And so that's that Pervious converted table. Now I want to do some additional calculations. I want to add fields because I want to add the costs to it, right? I have the area, but I want to calculate then the difference between the new and old areas and then calculate a cost. So I'll put in these variables to hold the space there. Then I'll calculate the two fields. So I'm going to calculate the first the pervious area added. And I do that by taking that mod area and subtracting the original area. Now, for the pervious surface, this will be a positive number because the mod area is going to be bigger. There's more pervious in the modified version than in the unmodified, and so the original will be smaller, and I'll get then a positive number. For the impervious, it'll be the converse of this. There's less impervious in the modified area, so when I subtract it from the impervious in the original, I'm going to get a negative value. I'll show that when I show you the table in a minute. And so I calculate that field, and then once I have the areas, I can then just multiply by the costs. Right, it's $150 per square meter times the pervious area added, and that gives us our cost output. Well, what does that perv area data layer perv convert look like? So if I pull it over and then I open it, right, I can see then that I have this impervious and pervious type from the original data. There's a frequency, the number of polygons, the original area, which I don't really worry about. I have a modified area and the original area, so these are two values. And then the pervious area added for the impervious, remember, it's going to be negative, and it's the converse of the pervious. So I've added here 12,335 square meters to the pervious type, right? It's the difference between the modified area subtracting the original area. And then I have also a cost, which is 150 times that. So it automatically generates that value. Again, you're going to have to generate it one way or another using a workflow or using a manual application of something like this. So I tend to commit things to workflows just because it's longer than 3 steps, because if I make a mistake in the workflow, I can track it down. And then once the workflow is set, I don't have to worry about it in Model Builder. I can just document it, and if I have to do this again, then change. If I remodify the surface, for example, for 5 versus 2.5 centimeters, I just then add that modified surface here, that different modified surface, and run my workflow again at the push of a button. So a couple of new things here, this table-to-table conversion, and the renaming here and altering the field, so the alter field tool.